Hi everyone, so in this video we're going to take a look at an exam question which is based around sort of the periodic table and a little bit of reactivity of group 1. If you want the background to this, I'd probably recommend watching the GCSE Essential Skills video 1 and possibly 2, because that's where most of the knowledge that I'm going to discuss in this video is sort of where we go through all of that. This is just how to approach the exam questions. So it says here, this question is about the periodic table. Sodium and potassium are in group 1 of the periodic table. Give one similarity and one difference between the electronic structures of sodium and potassium. Now, because they're asking me about the electron structures, I've got to talk about electrons. If I do any other things, like start talking about whether they're both metals or how their melting points might be different, I'm not going to get any credit for that. So the first thing we need to realise is that these elements are both in group 1. Okay, so if you take a quick look at your periodic table, you will recognise they're both in group 1 of the periodic table. And that is column 1, left hand side. So, similarity, they're both going to have one electron in the outer shell. So that's a nice easy one. If something was in group 2, they both have 2 in the outside shell. Now the difference, this is a little bit tricky. Now if you look at your periodic table, they're not going to be in the same period. So what I mean by that is they're going to be in different rows. So sodium is in row 2, potassium is in row 3, rubidium's in row 4, lithium's in row 2. That means they're going to have different numbers of shells. Okay, so essentially sodium has 3 electron shells, and then potassium has 4 electron shells. Okay, so that's a difference. Lots of students in this question, they will talk about other things. You're not going to get any credit if you mention other things that are not related to electron structures, okay, because the questions quite explicitly says that, and it also says give 1. So don't give more than 1, because the list rule will be applied, whereby if you give a wrong answer and a correct answer, the list rule states that you'll lose your mark for your correct answer because you've given more than one answer. So we'll move on to part 2. It says group 1 elements react with water. You've probably all seen this in your class with your teachers. It's the one where they put the water trough out and put the metals in, the fizz around. You probably all recall this. So it says give 2 observations when potassium reacts with water. So the first thing that you'll notice about these metals is they float on the surface of the water. Okay, and that's a characteristic of group 1 metals, and that's because they're less dense than water. That's why they float. The second one is the potassium melts. You can have that. You can also have a lilac flame. So any of those, any 2 of those are perfectly adequate. Now question C, it says potassium hydroxide is produced when potassium reacts with water. What colour of universal indicator, or what is the colour, sorry, of universal indicator when added to potassium hydroxide solution? Give a reason for your answer. Now the first thing I would say is potassium hydroxide, most of you will know this, but if you don't, a hydroxide essentially means that it's a base. And in 99% of cases it will be a soluble base, which means it's an alkali, but anything that's a base has a pH of more than 7. Okay, so universal indicator in this particular case, we can have blue, we can have violet, or we can have purple. Any of those are perfectly adequate responses to this. And the reason why we get those is because the solution is alkaline. Okay, so some nice easy marks there for those 2. So just be aware, hydroxide means that it is going to have a pH of more than 7 because it is a base. Right, let's have a look at this one. Now this is a little bit tricky. You will often be asked to do this in your paper, which is you'll be given some information and be asked to plot a simple graph and then read off that graph to find an unknown. Okay, so it says the table below shows densities of some of the elements of group 0 of the periodic table. So helium, neon, right down to radon. And they're asking us to plot a graph. Now thankfully for this one, they've already put the axes in place for us of atomic number along the bottom and density along the side, the y-axis. So first job is to plot our points. So helium has an atomic number of 2 and a density of 0.2. So this is quite a tricky one to do. So obviously in an exam situation, what I would recommend doing is trying to make sure that you use these small squares as a guide. Now we know on the bottom that one big square is 10, so each of these little squares is going to be equivalent to 2. Okay, and then up the side it's clear that a big square is going to be equal to 1, so each little square is going to be equivalent to 0.2. So just keep that in your mind whenever you're plotting throughout the whole of this process. And the essential thing is to use a ruler to read off. So you use a ruler to read off the points and then plot your points in. So helium, atomic number 2, density is 0.2. So the atomic number of 2, density 0.2. So I'm going to put a point, I'm putting a little dot there for that first one. And then it says neon has atomic number of 10 and a density of 0.8. So atomic number 10, density 0.8. I'm going the fourth square up because I know each square is worth 0.2, so that's there. Then I've got argon, atomic number 18, density 1.6. So I'm going to go, atomic number 18 is going to place me there. 1.6 will be the third square up from number 1. So that's that one. And krypton I can't do because we don't know the value. Xenon, atomic number 54, density 5.4. So I'll go across here. 54 is there. I'm going to read up. And then 5.4 is going to sit me around about there. Okay. And then radon is atomic number 86 and density 9.1. So 86 is 1, 2, 3 squares along. We'll go up and it's 9.1. So it's literally going to be right just in between the two squares there. Okay, so plot the data from the figure above. Now the next part is quite tricky because it's going to be wise to draw a line of best fit in this. Now obviously when you draw a line of best fit, what I would always say to you is you're going to be using a ruler to do that. And the ruler, you will get in the exam will be obviously your ruler that you bring into the paper. Now what I would say to you is if you've got a 30cm ruler, then absolutely use that ruler because it's going to help you out. Okay, so we've plotted our points and we're ready to do our line of best fit. Ideally you've got a 30cm ruler. They work best. A clear one is ideal because you can see through the ruler and it allows you to then see what points you're actually plotting. So we've got with our ruler, I'm just going to sort of move it around. So as you can see, I've got a bunch of green points. And my ideal scenario is it goes through the line of best fit. It's going to go through as many points as possible. If there are any that lay off the line, I need to make sure there's an equal number at each side. But that there looks like a pretty good place to place the line of best fit. So I'll put my ruler down. And then it's just a case of, in pencil, drawing that line of best fit in. Now, the reason I would say, obviously, in pencil is because if you do make any form of mistake with these, then you're going to have to rub it out. And we don't really want to be, doing multiple lines of best fit if you can help it. But a pencil does mean you can draw one. If you make a mistake, you can rub it back out. So let's have a look. So that's our line of best fit. And goes right through like so. Okay, so that is done. Now before we go on to the next question, the line of best fit, it's not an exact science. It's got to be as good a fit as you can get it. It might be subtly different to someone else's, but as long as it's in the right ballpark like this one, you'll be okay. So the second part now, it says estimate the density of krypton from the figure above. Now this is quite a tricky question because we've been given krypton's atomic number, which is 36, and we're going to have to read off the graph. So what I'm going to do at this point now is I'm going to take my graph and I'm going to be looking purely for the number 36. So I've got my ruler ready to do this, and I'm just going to swing the ruler right round and I'm going to align it straight, so we've basically got it lined up with the number 36. Now we know each square on the bottom is worth 2. So it's going to be 2 below 40, 36 is going to sit there. So what I then do is I will literally draw up from the bottom like so and see where it touches the line. And then again, the next part is just going to be a case of me just literally swing the ruler right round. Obviously it takes us slightly bit longer on the computer to do it than it is going to take you in an exam. And then again, just get as close as you can and read off that line there. Okay, so then I'm going to move the ruler out of the way and just take a look at the number and see what we've got. So it's looking there at the side pretty good, and I'm sort of 3.6 there. So 3.6 is my number. I'm pretty pleased with that. I think that should be okay. Obviously in these situations you're going to get a little bit of leeway. You know, the examiners will probably allow a range of 3 to say 3.8. You know, because everybody's line of best fit is going to be slightly different, so they've got to give you some leeway, and they will do that. But just a key point to be aware of: the examiners will be looking at your graph, so you've got to try and show you're working out on the graph. And obviously if I've got mine here and my graph's showing me 3.6, if I then write 3.4 in the question, I'm going to lose 1 mark for that, because my answer from this graph should be 3.6. So just be aware of that. I've done all my good work up there, that's absolutely fine, but don't forget to write your answer in the answer box. There's no point writing it at the top because nobody is going to look straight there. Let's just point it out to the examiner. So 3.6 is my answer for that one. So that's a graph. You do get them. Sometimes they're line graphs, sometimes they're bar charts. It's one of those. Just with this one, for those who don't know, the reason why I'm drawing a line graph in this particular situation is because they're both values are continuous number variables. If one of them, if I'd have been plotting the element against its atomic number, I would have been using a bar chart there. Okay, so just be aware of that. Now there will be people who find this next bit tricky. It's a little bit of group 7. So it says the elements in group 7 are called the halogens. A more reactive halogen can displace a less reactive halogen from a solution of its salt. Which combination of solutions will produce a reaction if mixed? So let's have a look. Chlorine and potassium fluoride. So is chlorine going to displace fluorine? The answer is absolutely not. Is chlorine going to displace bromide? Yes, it is. I'm just going to check the others, make sure I'm right here. Is bromine going to displace fluoride? No, it's not. Is bromine going to displace chloride? No, it's not. And the reason being, the most reactive element in group 7 is fluorine, because it's at the top of the group. And then as we go down, it's chlorine, bromine, iodine. And then the next one, this is all in the revision guides. Candidates should know the trends going down group 7. So as we go down a group, the relative molecular mass is going to increase, so the molecule gets bigger in mass. That's obvious from the periodic table if you look, but also what's not obvious is the boiling point increases as well. So as I go down group 7, the boiling point will increase, okay? And that's important because fluorine, F2, is a gas. If I go right near the bottom, not quite at the bottom, iodine is a solid. So boiling point increases as we go down the group. So the bottom box, relative molecular mass increases and boiling point increases. Them two questions, particularly the bottom one, they're just what I would call facts you just got to know about group 7. If you look in the revision guides, there's a little section on group 7 and group 1 where it gives you a little bit of info that you need to know, and it's quite explicit in the specification. It says candidates should know what happens to the boiling point as we go down the group. So thanks for watching, guys. That's just another chemistry question. There's more to come, so I'll see you in the next one.